Hello everyone. Today we are solving one-step equations. I think it's absolutely fundamental. It's probably, for me, this is like the major part of the fall semester for Algebra 1, where if you can wrap your brain around solving equations, perfect, okay? So let's get started. Make sure you have your notes today, okay? Again, we will be solving linear equations with one variable. Here. So your learning objective, we will solve one-step equations. At any point, y'all know you can pause, write it down. It is important to take notes, okay? Make sure you do that. So let's go here. Okay, we actually covered steps for solving equations before, but it's really important to this unit. So I want to make sure that you have it, okay? So this is in your notes, and I use the word SAD to remember the steps. S for simplify, A for adding, and D for dividing, okay? Excuse me. Essentially, when we simplify on both sides of the equation, that means that we have no parentheses and no like terms. Okay, this is just looking at one side of the equal side at a time, okay? 2, when we're adding or doing the additive inverse, essentially we are undoing the addition and subtraction aspect of an equation, okay? With dividing, 9 times out of 10, it's going to be dividing by the coefficient of the variable. But essentially, at this point, we are undoing with multiplication, most of the time division, and once in a blue moon, you might have multiplication, okay? The goal is, just remember, the goal for solving is to get x all by itself. Get x all by itself, to isolate it, okay? That's what we want to do. Let's go ahead and begin. Sorry, let me pause this real quick. Okay, our vocabulary word for today is equivalent equations, okay? So equations that have the same solution. Let's go ahead. Let me give you an example. Oh, I got a bunch of stuff on here I need to erase. Sorry. Okay, so for example, let me think. 3x equals 15, right? So here we know that what would x be? Well, x would be 5, okay? Because we could plug it in, right? We could say 3 times 5 would equal 15, right? So here we have one equation. An equivalent equations that have the same solution, might be something like 3x plus 2 equals 17. Okay, and so when I plug in 5 here, 3 times 5, still 15, right? 15 plus 2 is 17. So in this case, notice how the 5 worked here, and it also worked in here. So in both equations, x equals 5, okay? My counter example would be, remember, this is like an example that would not be equivalent. If we had something like 3x equals 15, which we know x would have to equal 5 for that to work, right? And then we also had 3x plus 2 equals 15. Well, as we showed here, 3 times 5 plus 2, that's 15 plus 2, is definitely not equal to 15, so it does not make it true. Therefore, these equations right here are not equivalent. Equivalent is just kind of a fancy way of saying equal. Okay? And here, we have equivalent expressions right here with this. And just, we're going to talk about a little bit that if you can kind of think about in your head, why is it? What did we do to go from here to here? Why are they equivalent? Okay, just for you to ponder. All right. Okay, so if you pondered that, let's look at, this is called the addition property of equality. If you think about an equation, right? Let's say we have 5 equals 5. They used 14. That's fine. But essentially, it's almost like a scale, right? Where we want it to balance on both sides. Now, here's the idea. If I add, let's say I add 2 to this side, right? And here, I'm going to add 2 as well, right? Which is plus 2, right? So is it still balanced? Well, 2 plus 5 is 7, and 5 plus 2 is 7. So that's still nice and balanced, right? Notice that we just added 2 on both sides, just like that example that I gave you, okay? So as long as you add the same number to both sides, shift. Am I shifting? No, I'm shifting this way. Okay. If I add the same number to both sides, I don't mess up the equation, okay? And it also works if I have, if I'm subtracting, okay? So I could say, let's say I have 5 on both sides. We know that's equal. If I subtract and I subtract 3, we still end up with an equation that is balanced and true, okay? So we haven't messed up anything. That's important when we get to this. When we have something like this and we want to manipulate and get h all by itself, we're going to have to be able to add on both sides in order to get h all by itself. So remember, solving, the goal is to get the variable all by itself. And I'm just going to write down sad. Oh. Remember, simplified. So I look over here. Is this simplified? Do I see any parentheses? Nope. Do I see any like terms? Again, no, because this has an h and this is a constant. So no, they're not like terms. And the same thing here, okay? If we have one term, it's simplified. The next thing that we're going to do is we're going to look at adding, okay? Or the additive inverse, essentially. So what we want to do is we want to undo this. We want to get h all by itself, and we want to undo this negative 12. Well, what is the additive inverse of negative 12? It's plus 12. If this had been positive 12, we would subtract 12. But we always just want to do the opposite. It's called the additive inverse. And what we just talked about now, in order to keep it balanced and not like whoop one way, is that if we add 12 here, we need to add 12 on this side, right? Okay, so now what I'm going to do is I bring it down. I have h. This actually zeroes out, right? Boom. 12 minus 12 is just 0, okay? It essentially goes away. It's not there. And then here we have negative 27 plus 12, different signs. So we want the difference, which is 15, and we're going to keep the sign of the 27. And so, ladies and gentlemen, our answer is h is equal to negative 15. Now let's test it out. So technically, if you test out all your answers, there is no reason why you should ever get something wrong. Our original equation was h minus 12 equals negative 27. I'm going to plug it in. Negative 15 minus 12. Does it equal negative 27? Yep, because they're the same sign, and we're going to sum and keep the sign of the larger number. So this is our answer. Hooray! Okay, the next concept is with subtracting. I guess I kind of got a little excited and ahead of myself there. But same thing, okay? We talked about if you had 5 on both sides, we could absolutely subtract 3 and subtract 3, and it still would be a true statement. We haven't messed anything up. It's still equal, okay? So we can add to both sides and we can subtract. Let's look at our next example. Right here. So let's follow the steps of SAD. And I'm going to pick a better color. Okay. The question we're going to ask is it simplified? Yes. Is it simplified? Yes. Great. Let's go ahead. You know what? I'm just going to... I'm looking at the terms, okay? So basically I put lines in front of pluses or minuses, and the equal also will separate things, okay? So here's our terms, right? We want to get the C term by itself, the variable term by itself. So who is with the C? That plus 102. We're going to do the additive inverse of that. The additive inverse of positive 102 is minus 102. And if I do it on this side, I must do it on the other side. When I say side, I mean the equal sign. I don't know if some of your teachers last year had you draw a little river, but that's essentially what that is, okay? So when we look at that, the C will come down. This zeroes out. And we end up with, oh, there's no sign, so I'm going to assume it's positive. I have different signs, so I want the difference. So really quick, let me do some like old school math here. Minus, I just want the difference. Carry, that's a 9, that's 1. We want 6, and that's 6, right? If I did my math right. So 66, and I keep the sign of the larger number, so it's going to be negative. And that's how we do that. Okay, and I think I did my math right, so hopefully it's good. Now, we can definitely check it. We can plug in that negative 66 plus 102 equals 36. So let me kind of set it up like this. 102 minus 66, and then we go over here, carry this, that's a 9, right? Put the little 1, 6, and 3, and we're good, right? I mean, it's the same problem before. So, yeah, this works. It's good. But now I know for sure, right? And there we are. Of course, at any time, if you have any questions, or that's not what I wanted, then make sure that you just ask me. Okay. Here's another concept. So again, along with the idea of having that balance, right? Let's say we start off with 5 and 5. We know 5 is equal to 5, right? If I want to multiply, let's say I multiply, as long as it's not 0, okay? I can choose anything like, well, let's choose 3, okay? If I multiply by the same number on both sides, did I mess it up? Nope. Okay, so we can multiply. So far, we can add on both sides, we can subtract on both sides, and we can multiply on both sides. Can I divide? Well, let's see. Let me go over here. Oh, you're going to be like that, huh? Okay. All right. So over here, they talk about division. Let's test it out with our little example. We have 5, and we have 5. Let's make it 15. And I'm going to divide by 3 this time. So we know 15 divided by 15 equals 15. That's true. And when we divide it by 3, as long as we do it on both sides, it's fine. Okay. And so that's true as well. So I think the general rule is that any operation essentially works, but whatever you do on one side, you need to do the other. And this is called balancing, okay? It's the process of balancing, because the whole idea is that you want to keep it like a scale, and you don't want to ever put one more weight on here. If you put something here, then you need to put it on the other side. And in the middle, you have your equal sign, okay? Okay, example 3A. Let's go ahead and try this one out. So here, simplified, right? Here, simplified. I mean, it's just one term. There's nothing else you can do. Now we need to identify our variable. We have b, right? What is going on between b and 15? Okay. If you said multiplication, beautiful. Okay. This is the last step. It typically divide, right? It typically is division, occasionally multiplication, okay? But it typically is division. So the idea is that you are undoing multiplication or division. So if I'm multiplying, I'm going to divide by 15, divide by 15. Okay? Let me go here. All right. So 15 divided by 15 is 1. These essentially cancel out. And you end up with 1b over 1, which is b. Then we have negative and we have a positive. This is where I use Dorito Dude. If you have another method, by all means. We have a negative divided by a positive, so we're going to end up with a negative right here. Our answer is going to be negative. And if you can do 75 divided by 15, awesome. I feel like I'm going to struggle with that a little bit, so I want to divide by 5 here, and I want to divide by 5 here, okay? So on the bottom, I know I'm going to have 3, and on the top, I'm going to have 15. Okay, so now that's easier for me to simplify. Negative 15 divided by 3 is 5. And so, ladies and gentlemen, b is equal to negative 5. And I can always test it out with my calculator. Put it in. 15 times negative 5 is negative 75. Okay? Write down all questions that you might have. Okay, example 3b. We are going to solve this. I think the first thing that we should do is change all proper fractions to be improper. They're way easier to deal with that way. So remember the rules when you were like in middle school, right? You had to multiply. And honestly, we're going to leave the negative on the side. We're not going to deal with that one right there. We're just looking at the 1 3/8. So we're going to multiply, and then over here we add, okay? So that's going to look something like, I got the negative on the side. I have 8 times 1 plus 3, and then we put that over 8. K equals 2/3, okay? Now, 8 plus 3 over 8, and that's 11 over 8, K equals 2/3, and I'm just going to keep writing that down. Okay, so now this is a much better place to start, okay? So I will let you know that this is the same as this, and the same as this. Okay, so you can put the negative wherever it suits you best. For my explanation, I think I'm going to put it on the top. Why not? So here we are. I'm going to rewrite it. Okay, equals 2/3. The goal of solving an equation is to get k in this case all by itself. So what I want to do, we're looking at SAD. We have one term on each side. There's nothing we can do. Basically, adding to get terms away. Well, we only have one term, right? Everything is being multiplied or divided. So that's what we need to focus on is D, where we undo the multiplying and the dividing, okay? So the first thing, when we look at 8, please keep in mind, what is it doing in relationship to K? Since it is on the bottom, okay, it is actually dividing. So to undo the division, we have to multiply. So here we are. We're going to multiply by 8. And if I do it on this side, I have to do it on this side as well, right? Now, 8 divided by 8 goes away. That's the beautiful thing about it, right? It's just 1 and 1. It goes away. So here I'm left with negative 11K. That's already cleaned it up a lot. And then I have this. Okay, remember, we're just going to put it over 1. So 2 times 8 is 16, and 3 times 1 is 3. Okay? I want to get rid of all denominators. That's usually my goal. Like, let's just get rid of the fractions. And the way we can do that is by multiplying by the denominator. Although, and I typically say that, although we had said that the goal was to get k all by itself, right? So you could get rid of the 3. But I think in order to keep this simple, let's just go ahead and deal with getting k by itself. What's going on between k and negative 11? Multiplication. So to undo that, we have to divide. Good. We're going to divide by negative 11, okay? And dividing by negative 11 is the same as dividing by a negative, like that. That's 1 over negative 11, right? Let me make sure that y'all understand. Dividing by negative 11 is the same as basically multiplying by 1 over negative 11. Let me give you an easier example to think about it, okay? If I told you I was dividing something by 2, that's the same, like 2. 10 divided by 2 is 5, right? So if I'm dividing something by 2, that is the same as multiplying by 1/2. Do you know the relationship? We did actually have this vocabulary word. The relationship between 2 and 1/2? It's the reciprocal. So reciprocal, reflippical, okay? Reciprocal, reflippical. Now, the thing is, because we have a whole number, it's really just over a 1, right? 2 over 1 is the same as, is the reciprocal of 1 over 2. Think about it like this. If you have $10 and I want half of it, how much money am I asking for? $5, right? Okay, so just know that when we're dividing here by negative 11, it's the same as multiplying by 1 over negative 11. So the negatives cancel because a negative divided by a negative is a positive. 11 divided by 11 is 1. And then we have the k. Over here, there are no factors in common there, so we're just going to multiply straight across. 16 times 1 is 16. And 3 times negative 11 is negative 33. This does not reduce. There's no factors in common. And so as a result, we really don't need the plus. We really don't need the ones because those are kind of like ninjas. They're there, but we don't have to write them. And then I'm just going to put my minus up out front. And this is going to be our final answer. Okay? I will tell you, 9 times out of 10, I want all answers as improper fractions. I believe this is the last problem, so yay. Okay. Travel. Ricardo is driving 780 miles to Memphis. He drove about 3/5 of the distance on the first day. About how many miles did Ricardo drive? Now, I like to think of it like this. I'm going to draw. Do I have any tools? No. Okay. I just kind of like to divide stuff up. Sometimes I just have a plan, right? Here's what we know. We start off with what we know. This is identifying what are we trying to figure out, okay? What is it that we're searching for? Trying to figure out, okay, what is it that we want to know? That's usually reading the last question. And then here's our process and conclusion. And then finally, we do want to check it. Who doesn't want the right answer on the test, right? Okay, so start off with what we know. Numbers are usually a good indication. We got 780 miles to Memphis. Got it. 780 miles to the big M. Okay, he drove about 3/4 of the distance on the first day. So here's the entire, like here's San Antonio, SA. And I don't really know if it's this many miles to Memphis. I doubt it, but I'm just for perspective. San Antonio to Memphis, okay? And he went about 3/5 in one day, okay? So that means if we take all of this and we break it into like 5 chunks, 1, 2, 3, 4, 5, that means that he was able to actually go about this much and this much and this much. Can you tell like I'm crazy visual? So 3/5 of the distance on day 1. Okay, that's my little notes. What are we trying to figure out? So often students fail to read what the question's actually asking for. Always go back, maybe underline it, but it says about how many miles did Ricardo drive, okay? They want to know the number of miles. That is what our variable is going to be. I'm going to call it X because I'm incredibly creative. There we go. X is the number of miles. Now, that he drove, that recorded. Okay, so the number of miles, just to be, that Ricky, I'm going to rename him, drove. Okay, so here is our process. My thought is maybe using a little dimensional kind of thing, some thought. We start off with what we know. Okay, there's our variable. And I want 3/5 of it. So now, just kind of some logic here, just some like math sense. Am I looking for a number that is going to be bigger or smaller than 780? Okay. If he only made it 3/5 of the way, right? He didn't make it the entire way. We know the whole way is 780. If he made it just part of the way, it's probably a smaller number. So I'm going to make a note. Hey, probably smaller. If I got a bigger number, I probably did something wrong. Probably smaller, right? Okay. So now, if I multiply by 3/5, then that should do it, right? Okay, so I'm going to go ahead and I'm going to put this in my calculator. 780 times 3 divided by 5. 1 second. Give me a second. All right. So I'm looking at 468 miles, which is a number smaller than 780. Perfect. Okay, I want to double check. Okay, so ways that we can double check. Well, we could, if I know that's 468, right? And that's, if I divide it by 3 to get like each one of those little fifths, right? Divide by 3. And then I multiply it by 5. I should get 780, right? And so I'll put it in my calculator. I got 468 divided by 3, and I get 156 times 5, and multiply that by 5. Ta-da! It works. Yay! Okay, so we have successfully figured out and calculated the number of miles that Ricardo drove on day 1. Look forward to seeing you at your live session today. Take care. Bye-bye.